The increasing demand for sustainable energy has led to the growing interest in biodiesel or fatty acid methyl ester film, produced from lipid-rich sources. The biodiesel production process involves three key steps: lipid extraction, transesterification, and purification. Traditional catalysts, however, have significant limitations. They often require high temperatures, generate hazardous waste, and are difficult to separate from the reaction mixture. This is where ionic liquid or ILs come in as a promising alternative. So specifically, Di-Cationic Pyrrolidinium-based Ionic liquid offer advantages like high thermal stability, non-toxicity, and versatile solubility. Additionally, when immobilized on biomass supports like bamboo, these ILs become easier to separate, improving sustainability of the process. Our goal is to develop novel heterogeneous catalysts by immobilizing mono and dicatonic pyrrolidinium ionic liquid on bamboo biomass to enhance film production efficiency and overall sustainability. A study by Hasanuddin et al. In 2022 explored biodiesel production from microalgae using pyrrolidinium-based ionic liquid as catalyst. The research compared the same two catalysts that is used on this project, which is the dicatonic IL and monocationic IL. Results showed that the dicatonic IL outperformed the monocationic IL, producing 87.9 mg per gram percent of film versus 74.3 mg per gram percent. The dicatonic IL higher acidity made it more effective, especially at lower concentration, making it a more cost-effective option for biodiesel production. Therefore, exploring the potential of this IL as a heterogeneous catalyst will be a great key forward of this research. The project started by synthesizing the ionic liquid through a quaternization reaction, and then characterizing them to confirm their properties using NMR. Next, we prepared bamboo activated carbon as a solid support with the assistance of tube furnace. We then immobilized the ionic liquid using the wet impregnation method. For the biodiesel production, we applied direct transesterification with microwave assistant and optimized the process using the Taguchi method. Finally, we analyzed the fatty acid methyl ester film produced using GCFID to evaluate the efficiency of the process. Moving forward to the result and discussion, in our analysis of BET and SMM result, we observed that the impregnation of ionic liquid on bamboo activated carbon significantly enhanced the material's properties. The BET surface area increased to 1444 meter square per gram for the 30% IL1 BAC sample, indicating a more porous structure that facilitates better IL distribution across the BAC surface. This improved distribution leads to the enhanced catalytic performance. For instance, the 30% of IL2 BAC sample showed a BET surface area of 1238 meter square per gram, with a notable increase in pore volume, which supports greater accessibility for reactants. These changes suggest that the ionic liquid not only improved the catalytic activity, but also optimized the structural characteristic of BAC for biodiesel production. We used the Taguchi method to optimize biodiesel production conditions, evaluating various factors such as catalyst loading, temperature, time, and methanol volume for both IL1 BAC and IL2 BAC. The optimal conditions identified by the software showed that for IL1 BAC, the best catalyst loading is 3 weight % at 75 degrees Celsius for 60 minutes, yielding 82.32 mg per gram. In contrast, for IL2 BAC, the optimal conditions are 6 weight % catalyst loading at 60 degrees Celsius for 15 minutes, achieving a yield of 63.55 mg per gram. Comparing this result to homogeneous ILs, we see that optimized heterogeneous ILs use significantly less mass, only 0.009 gram for IL1 and 0.018 gram for IL2, compared to 0.035 gram and 0.03 gram for homogeneous ILs respectively. This reduction in the amount of IL used not only enhanced the cost effectiveness of the process, but also improved sustainability, demonstrating the advantages of using immobilized ionic liquids in the biodiesel production. This project introduced the first use of mono and dicatonic pyrrolidinium-based ionic liquid on bamboo activated carbon for biodiesel production, reducing the amount of ionic liquid needed and utilizing biomass as a sustainable support alternative. It also shows significant benefits, including easier catalyst separation and lower production costs by using renewable bamboo. It enhanced efficiency by achieving high film yield with less catalyst. Significant benefits to society include supporting renewable energy and boosting local economies. It promotes greener biodiesel production through renewable biomass and reduced waste, while minimizing ionic liquid use to address disposal issue and support circular economy principle. From a commercialization perspective, it lowers catalyst costs and waste, enhancing competitiveness for producers. The bamboo-based catalysts are easily scalable for industrial use and meet the growing demand for efficient, cost-effective, and sustainable solution with a less ionic liquid.